vectors are very useful in physics to represent force because force has both magnitude and direction. So if several forces are acting on the same object, the resultant force experienced by the object is the vector sum of those forces. Now consider a force acting on a single point with a magnitude of 13 pounds and the direction of 60 degrees, and another force of 18 pounds in the direction of 0 degrees. And let's have a third one, and let's say it has a force of 11 pounds acting in the direction of negative 30 degrees. So what's the resultant force vector? In other words, with all these three forces pulling on this object at different directions, what's the resultant force, or what force is experienced by the object? Well, let's start off by drawing a picture of this thing. So let me see here. There's my y-axis. Here's my x-axis. Now, the first thing I have is a force of 13 pounds in the direction of 60 degrees. So that's roughly 60 degrees. I'm going to say that this has a magnitude of 13. Now, 60 degrees is the same as pi over 3. Now, we typically think easier in terms of degrees, but I'm noticing this. These are all common angles, so when I start dealing with finding sine and cosine of these angles, personally, I'd rather work in radians. But I'll also note here that this is 60 degrees. See, I had a force of 18 pounds working at 0 degrees. Let's see if this is 13. Then 18 must be, roughly here. So I'm going to have this vector at 0 degrees, and it has a magnitude of 18, and this is 0 degrees and radians, whatever. And then I also had this last one of 11 pounds working at, let's see, what do I have here, negative 30 degrees. So that's 13, the 11 is going to be roughly here. So something like that. This is 11 pounds. And negative 30 degrees is actually the same as negative pi over 6, which I'll also note as being negative 30 degrees. So you can think of that of any way that you want. Now, when I start thinking in terms of the resultant force, at what angle and what magnitude is this thing feel like it's being pulled at? Well, if I take a look first of all at this first vector, the resultant force, what it's feeling going in terms of the x-axis, let's see here. I didn't label this. This is the x-axis, obviously, and this is the y-axis. So I want to think in terms of relative to the x-axis, what is this thing experiencing? Well, what it's experiencing is if I drop a perpendicular here, it's experiencing this component right here. Well, if this is theta, then this component must be 13 times cosine of theta. So this very first component is simply going to be 13 times cosine of theta, which is cosine of pi over 3. Again, personally, if I'm dealing with common angles, I'd rather work with radians. And I'm talking about in this direction right now in terms of x. I'm going to add to it, see what's next. Well, I have 18 pounds. I'm going in this direction, so this is going to be 18 times cosine of that angle. Well, this angle is going to be 0. Plus, well, if I drop a perpendicular here, this is going to be a component that's going to be realized by this vector. So it's going to be 11 times cosine of negative pi over 6. Now, all of this is going to be the I component. I need to add this to the J component. And the J component is going to be the component that's working along the y-axis. Well, that's going to be, for this first vector, it's going to be this component right here. And that's going to be simply 13 times the sine of pi over 3. That's that component. Now this component in the vertical, or the vertical component of this vector is going to be 0. We can see that. But it's going to be 18 times sine of 0. Sine of 0 is 0, so obviously you can see with this vector it's not giving anything or lending anything to the vertical component. Plus, this is going to be the component vertically. So this is going to be 11 times sine of negative pi over 6. And that is going to be my j component. So when I work this out, I am going to have, let's see here, 13 times cosine of pi over 3 is a half, plus 18 times cosine of 0 is 1, plus 11 times cosine of pi over 6. Pi over 6 is a root 3 over 2. It's negative pi over 6, but it's still cosine is positive in that quadrant. So this is going to be, let's say, root 3 over 2. That's going to be in the I component, plus the j component, which is going to be 13 times sine of pi over 3. Well, sine of pi over 3 is root 3 over 2, so this is 13 times root 3 over 2, plus 18 times sine of, plus 11 times sine of pi over 6. Well, sine of pi over 6 is a half, but negative pi over 6 is negative 1/2. So this is actually going to be times, well, I'm going to write this as 1/2 and simply change this to a negative. And that's the j component. So if I start doing some addition here, what I'm going to end up with here is the force vector is going to actually be equal to 13 plus 36 plus 11 root 3 all over 2 I plus 13 root 3 minus 11 over 2 j, which I guess I can simplify a little bit and say this is 49 plus 11 root 3 over 2 I plus, oops, let me see here. That's 13 root 3 minus 11 over 2, over 2 j. So that's going to be my vector. That's going to be the force vector. Let's take a look at this and figure out, see if we can make a little bit more sense out of it, because off of that I'm not sure if we can quickly and easily visualize where it is. Obviously the I component is positive, so it's going to be in this direction. The j component is obviously positive. 13 times root 3 is bigger than 11, so it's going to be an angle somewhere in here. But let's take a look at this, do a little bit more work with it, and see if we can figure out what's going on. Now the magnitude of the force vector is going to equal the square root of, I'm working with this now, let's see, 49 plus 11 root 3 over 2 squared plus 13 root 3 minus 11 over 2 squared, which is approximately 34.51. So I know that the length of this vector is going to be approximately 34.51. Now I need to figure out what the angle is going to be. Well, tangent of theta is going to be the y component over the x component. So this is going to be 13 root 3 minus 11 over 2, that's the y component, over the x component, which is 49 plus 11 root 3 over 2. Obviously the 2's are going to cancel, which is going to give me 13 root 3 minus 11 over 49 plus 11 root 3. So tangent, well, if I actually grab a calculator, this would be approximately 0.16923. So that's the tangent of the angle. That means the angle, actual self, theta, is going to be equal to arctan of this, 13 root 3 minus 11 over 49 plus 11 root 3, which is going to be approximately 0.16764 radians, which is, if I take this thing and I multiply it by 180 over pi, I'll get approximately 9.6 degrees. So 9.6, roughly 10 degrees. So that's 45. 10 is going to be somewhere in here, give or take a little bit. And a length of 34. If this is 18, double this is 36, a little bit less, 34, right about here. So this resultant force vector is going to look something like this. So in other words, all three of these vectors here, this vector, and this vector, can be replaced by the single resultant force vector right here, with, where am I now? This magnitude and this direction.